Hello everyone, and welcome to Mr. C's virtual classroom. Today we will be going over the Pythagorean Theorem. The objective of the lesson is to have you students use the Pythagorean Theorem to determine unknown sides of a right triangle. Students will need a paper, a pencil, and a calculator. To begin, we need to know the equation that we will be using throughout the lesson. The Pythagorean theorem states that the square of the hypotenuse is equal to the sum of the squares of the other two sides. The largest side of the triangle is the hypotenuse. It's labeled as C in our equation, and it's the side opposite of the right angle. The other sides will be labeled A and B in the equation. The equation is a squared plus b squared is equal to c squared. We know this equation to be true thanks to Greek mathematician Pythagoras. This rule had been known for a long time, but Pythagoras was the first to prove this law. Now we'll be trying to prove this equation, a squared plus b squared equals c squared. We will start the proof with 4 copies of the same right triangle, 3 of them rotated at 90 degrees, 180 degrees, and 270 degrees. Each triangle has an area of AB over 2. If you put all 4 triangles together, they form a square with side C. This is the example of the square. The square has a square hole with the side a minus b. Considering its area would be a minus b squared. You add that to the area of the 4 triangles, which would be 4 times AB over 2, and that equals 2AB. Therefore, C squared is equal to a minus b squared plus 2ab. You expand. C squared equals a squared minus 2ab plus b squared plus 2ab. Combine like terms, and it would be c squared equals a squared plus b squared, our equation. The first step is to plug in the known variables into the equation, a squared plus b squared equals c squared. We substitute a with 3 and b with 4. Now we square both sides. 9 plus 16, do the addition. Comes out to 25 equals c squared. But now we have to find the square root. So we take the square root of both sides, and the answer comes out to be 5. C equals 5. For this example, we will be working with a right triangle with the side B unknown. A is equal to 5, and C is equal to 13. Once again, we begin by plugging in the known variables into our equation. 5 squared plus b squared is equal to 13 squared. Square both sides. Comes out to 25 plus b squared equals 169. Now we subtract 25 to both sides, coming out as b squared is equal to 144. Now we have to take the square root of both sides. Square root of 144 is equal to 12, and b is equal to 12. Okay, now students, it is time to practice what you have learned. Please do these problems on your own. You can pause the video and write down the information to work on it. Once the video is continued, you will be shown the explanation and the answer. In this problem, C is unknown, A is equal to 8 and B is equal to 15. We are to use the Pythagorean theorem to solve for C. Here's the solution to the first problem. In the second practice question, B will be unknown, A is equal to 7, and C is equal to 25. We are to use the Pythagorean theorem to solve for B. This is the solution to the second practice problem. Let's go over everything you've learned today. The hypotenuse is labeled as C. C is the longest side in a right triangle. The other two sides are labeled as A and B. The Pythagorean theorem is used to find the unknown lengths in a right triangle. And the equation used with the Pythagorean theorem is a squared plus b squared equals c squared. Check back later for more lessons in Mr. C's virtual classroom.